All right, this is Dmitry, and he's going to be talking about yes, SAP passwords. So go ahead, go for it.
Okay, good morning. As you heard, my name is Dmitry Chastuhin. I work for a scan company, and today I will tell you how to compromise SAP systems via SAP users' password disclosure. I think this talk will be useful for penetration testers who often see the SAP systems in a corporate network but do not know how to get in. So, the company I work for is called scan. We are the developers of security products for SAP and blah blah blah. A little bit about me. I have a difficult surname. I work in the field of information security and in particular business application security. What's more, I and my friends are the organizers of hardcore security conference in Russia. It's called Zero Nights, so if you want to visit Russia, you're welcome. And of course, I want to apologize for my very bad English. So, but by the way, I will try to describe the slides. So, who knows what is SAP? Oh, it's cool. So, SAP is the most popular business application. More than 250,000 installations all over the world, but people spend an enormous amount of money to install it and then forget about security. By the way, in ERP systems, all business processes are performed, all critical information is stored like in financials, HR, clients information, and not to care about the security of this data is not very sensible. That's why we try to compromise the systems. And in the world exists a myth that SAP is not accessible and can be attacked from the internet. This is wrong. The system become more and more popular, cloud service and mobile solution appears, so more and more SAP services become accessible from the internet. We have scanned the internet for various SAP services and aggregate all this information at our sites, on our sites. But I will say quickly, we found a lot of different open SAP ports which can be accessible from the internet, and that's why anyone can compromise a very big company through the SAP. One of the services is SAP MMC, or SAP Management Console. This service provides a common framework for centralized system management. Using this SAP MC, SAP administrator can monitor and can control SAP system, start or stop or restart the instance, displays some trace files, log files, start profiles, etc. But the main things, main attack on SAP MMC can be implemented without any notification. Attacker can send a few swap requests and got information from SAP server. For example, this is how an attacker can easily get content from any file from the SAP server. Just using function read log file without any notification, attacker can read log file, for example, but any other file from the system. Via vulnerabilities which allow to read any file from SAP operating system is important, because SAP stores a lot of sensitive information in files. It can be log files, trace files, some configuration or properties files. Of course, most of them, especially critical, have a protection like encryption. But today I will show how you can bypass these encryptions. And if an attacker can read file from the server, they can get clear text passwords of SAP users and as a result compromise the SAP system. SAP has a lot of different vulnerabilities which allow to attacker read any file from the operating system or execute command got a remote command execution. Just view our previous presentation about that, and you will find a lot of information about these vulnerabilities. But in this talk, I will show where attackers can grab some SAP password, and if they have access to the same files on the SAP's file system. It is talk based on reverse engineering of few SAP services which work with user passwords. That's how we got information about it. And it's cool. It's very important for us. Okay, default. Yeah. Oh. Yeah. It's normal. Okay. Yeah. It's work. Okay. I can start. Okay, the first area, default passwords. Everybody knows about SAP have a default usernames and passwords. There is on the slides, but the problem is everyone SAP administrators change this default passwords on main mandant, but they forget about other mandant like 000 and 001 or 066. That's why often we can find this default password for critical users on the SAP systems. It's very easily to you find a SAP system, try one of these username and passwords, and you will get full access to the data. So let's start with the passwords on client side. How attacker can compromise or got access to the client side. All SAP users use for communicate with SAP system the client called SAP GUI, and the SAP GUI use a lot of different ActiveX components for their works. That's why attacker can use this ActiveX for attack the clients. We found a lot of different vulnerabilities in ActiveX which allow us to execute operating system command on the client side or read any file from the client side. By the way, we also found different buffer flow vulnerabilities. But what after that? How we can use it? We can read the SAP logon shortcuts. Often lazy users or SAP administrators store password for SAP account in shortcuts. That's how its typical shortcuts look like. Information about some connection string and information about passwords, or like that. So this is string with encrypted password. PV, just a static char. After that goes the encrypted password. In my shortcut, I saved default password 06071992, and as a result, I got this hex string which looks like a XOR encrypted password. And after, as you know, we can easily get a key. We check this key on the different version of SAP GUI, understand the key is static and equal for all SAP GUI installation. The key starts with 788, and on this slide and the next slide I will not publish the encryption keys because we have some agreements with SAP company. By the way, if you will send me a message or something like that, of course I will give you all this key and tool for decryptions if you wanna. And of course little Python code to decrypt the password from SAP GUI shortcuts. And a little bit information about how to prevent and protect your system. Go next. Password from user 02, user password02 and user PVD history tables. This is the most well-known area about SAP user passwords. In these tables, SAP store all information about user, mandant, name, password, hash, etc. So if an attacker can read these tables, he will get a lot of interesting information about users. But what important information about password hash. For hashing, SAP use few algorithms called them A, B, D, E, F, G, H, I. First 5 of that algorithm I do not recommend to use. This hash use only first 8 chars of passwords and do not see a different case sensitivity. That's why this hash very easy to brute. Other of them based on the SHA-1 algorithm, but the way you still can use the John the Ripper for brooting them. And few prevention notes how to protect user hash. Not so interesting. Go next. Password from RFC request. RFC, it is remand function call. RFC need for communication between different SAP system, SAP and non-SAP system, and of course for executing some users request. So this means SAP use RFC requests very often. This is how RFC request looks. As you can see, I hope you see, all data transmit without any encryption. You can see username, function name, but you will not see the passwords because only user password was encrypted by default. And as I said, if an attacker will intercept the RFC request with login data, he will be happy because he got the login and password. But after that, he understands the password is not clear text because the password is encrypted. And after a few experiments, we found again XOR used for encryption and again static key. So that's why it's if you intercept RFC request with encrypted passwords, you can easily decrypt them. For secure system, just use an SNC. The next client-side application which will be described, it is SAP Visual Administrator. SAP Visual Administrator, it is a remote tool for controlling J2E engine, which used in SAP system. This tool uses a proprietary P4 protocol, and by default, all data transmit in clear text except passwords. That's how protocol looks like. Because Visual Administrator it is a Java application, we can easily decompile them and understand which encryption is used. And again, XOR as you can see, all password chars XORed with the static hex value AAA. And once again, the key is hard-coded, and all version of Visual Administrator is the same. And go to the server side of Java stack. Start with Java security storage. What is that? The security storage, this is a place which Java application server use for storing sensitive information like a database user's name, and it is passwords. Database connection information and administrator user for that, and administrator username and password of SAP user on the operating system. Security storage placed on the file system in file store.properties. On the slide you can see the default path to this file. So looks on this file, you can see the words like a host, password, etc. But the value of these things is encrypted, of course. Our research shows for encryptions, SAP use triple DES algorithm. Okay, now probably we need a key for decryption this stuff. There is the main problem of Java security storage. The key file is located in the same directory as the encrypted data in file chastuhin.key. That's why if an attacker can read encrypted passwords, and if an attacker can read file with encrypted data, he also easily can read the key for decrypt all the stuff. If we look deeper on this key file, we will see it consists of two parts: version information and encrypted key phrase. Version information. Depending on version, the triple DES key may be changed. For example, if version of key files above 7.0, this means key equal key phrase plus SID of SAP. The next one is encrypted key phrase. By default, it is an initial password which the administrator set up during SAP system installation. Often this phrase equal to the database passwords or an SAP administrator password, account password. For encrypting the key phrase, XOR algorithm with static key is used again. That's why if an attacker only got the chastuhin.key file with encrypted phrase, they can also get access into SAP because they have the initial passwords. Okay, now we have the encrypted passwords from chastuhin.properties files, and we have the decrypted key from the file chastuhin.key, and now we can try to decrypt data from chastuhin security storage, and we successfully do it. As I said, data is encrypted by the triple DES algorithm in CBC mode using a secret key which is derived from a password with SHA hash algorithm. The key is the key phrase from chastuhin.key plus SID, and the result is 0. That's all, very easy. We also wrote a tool which decrypts all this stuff from SAP Java application security storage and successfully used it on our SAP pen test. It's, as I said, it's very easily to find a vulnerability which allows us to read any file from the server. We read these two files, decrypt passwords, and boom, we have access to database and fully compromise SAP system. Also, SAP security storage file can have another name like gupgrade.properties and store other interesting information like a password from SAP operating system username, database passwords, some usernames and password from SAP. A little bit about prevention: install these SAP nodes, and of course restrict read access to the critical files. The next one thing, log and trace files. SAP can write a lot of logs, and administrator can define which logs and the verbosity level of these logs. And if an attacker can read logs, for example, via SAP MMC, for example, he can find many interesting things in log files. Information about the system, information about the user, information, even session information. But administrator, as I said, can configure logging. By the way, in SAP systems exist few places where logs store does not depend on the desires of administrator. For example, log files from SAP inst directory. This directory stores the files which used during SAP installation processes, and in this folder attacker can find many interesting log files. Let's see on these files. They are typical log files from this directory. As you can see, the password is replaced. Okay, go to the next slide. Yeah, looks better. Attacker can find the clear text username and passwords in log files. But be honest, this situation does not happen so often. So go next. This is more real situation which we see very often in SAP logs. Password is encrypted. Guess what type of encryption is used? Right, again XOR, and again the key is hard-coded, and as a result we have a decryptor of password from SAP logs files. A lot of critical usernames and a lot of passwords we can find on these logs. The same story with some auto-generated configure files. You can find a lot of encrypted logs, password in logs. Goes the next, the SAP modules, SLD. SLD is a central information repository for SAP system landscape. It contains information about technical system landscapes, business system products, etc. So of course SLD has a config file. Its name is sld-desk.cfg, and it stores information about username, user passwords, hostname, and port value. And all this stuff is encrypted by DES algorithm in the early versions of SLD. In the older version, and the new version used triple DES algorithm. By default, for encryption, SAP used default hard-coded key. Part of this key you can see on this slide. But user can, administrator can change the default key. But if he changes the default key, the key will be random generated and will be saved as sld-desk.kfg.key and place it near the encrypted data. And again, we can read the file with encrypted data and read the key with encrypted key. So that's why the key is not a problem. As I said, in the latest version of SLD, another algorithm is used, is triple DES with hard-coded key. A little bit about prevention. Okay, go the place where ABAP stack stores sensitive information. ABAP security storage. The security storage is a component of SAP application server. It allows the encrypted storage of sensitivity data that SAP application require while logging into other systems like RFC destination, exchange infrastructure, SAP Home, SAP HANA, etc. And all this data store is encrypted in SAP table rsectab. How to get access into database? A lot of ways exist. If an attacker can execute operating system command on SAP server, that means he has opportunity to connect to database without any credentials. And after that, he easily can read table rsectab. How SAP encrypt this data in security storage? First of all, SAP create this structure in different versions, different structure. Besides data, also encrypted some additional information like SID, instance number, and some magic values which will be used later. That's how this structure looks. Starts with random numbers, after that payload, and after that some signatures, checksums, and SID. For encryption, the triple DES algorithm uses the DES ed3 method with 24 bytes keys is supplied. This means there are 3 DES operations in the sequence encrypt, decrypt, encrypt with the 3 different keys. Okay. The first key will be bytes from 1 to 8, the second key bytes from 9 to 16, and the third byte from 17 to 24, and 2 rounds of encryptions. First round, it's one On this step, SAP encrypt only part of our data. It is random prefix, payload, payload length, etc. Key for first round encryption generate dynamically and based on the default key, which XORed with MD5 hash of SSID of the system and installation number. About the default key, I will tell a bit later. So after the first round, we got this picture, the bigger part of data already encrypted, but part of this which used for generating first key still in clear text. That's why we have a second round of encryption. As key, SAP used default key value, and as a result, after second round, we will get encrypted data. And all this data placed on SAP table RSec tab. What about the default key? It is encrypted via SSID ED2, but the key for the encryption is hard-coded. So SAP system store encrypted key and before first round decrypt this key using another hard-coded key. That's how we'll get default key value. After that, we can decrypt the second round of encryption, and as a result, we get information which allow us generate a second key and decrypt first round, and we get clear text data from ABAP security storage. The protect and prevention is very easily. You need to just change the default key, but in my practice, nobody do that. Okay, let's go to another interesting table, dbcon table. As you know, SAP has a connection with a different database, and administrator can manage this connection via the transaction dbco, and we'll get information from database, some kind of statistic. All database connection information which used in dbco transaction is stored, encrypted in the table dbcon. Let's see on this table. That's how dbcon table looks. Information about connection, username, and password, of course. And on this slide, you can see example of an encrypted data. So for encryption, used this algorithm, and after encryption, the result is encoded using base 64 algorithm. The key which used for encryption again is hard-coded. You can see on the slide. And this key is equal on different SAP system. That's why we can easily use it on the pen test. With payload, also encrypted static salt. Be happy. And a little bit about prevention. And the last SAP models, which I will describe, it is one of the new SAP product in memory database SAP HANA. I do not have enough time for reviewing the system. Just go to password issues. A lot of interesting things HANA stored in HDB store, HDB user store. It is kind of SAP ABAP security storage. The default location of this storage is on the screen, and all information placed in file sf hdb.dat. As in ABAP security storage, HANA used triple-dash algorithm, and what interesting, HANA used for encryption the same default hard-coded key. What kind of information we can find into storage except the passwords? As I said, SAP HANA it is a in-memory database. That's why attacker can steal information from DB file from file system. He can steal this information. By the way, HANA drops some data into file system, backups and save points. After a power fail, the database can restart like any disk-based database and returns to its last consistent state from save points. That's why HANA provide data volume encryption, which allows to administrator encrypt volume using IS algorithm. And for decryption, volume, HANA use persistent encryption root key, and these main things. Where the key is stored? Right, in file SSF hdb.dat. That's how attacker will get a root key and bypass volume encryption. Also, some internal key plays there. They use as signing some internal API requests. Yeah, 2 minutes. Okay, little bit about prevention on this slide. And finally, I want to say I don't have enough time to describe all possible ways to get SAP user passwords. By the way, if you just try to grab and try to find in DB using the word passwords, you will find a lot of interesting places where password in SAP system may be stored. That's all. Thank you very much. Of course, as I said, if someone needs all these key and tools for decryption, you're welcome. Ping me and you will get it. Thanks.